Hi there. I'm assuming that you have looked at the prerequisites and the intended audience for this course. I should mention that we will be using the word class or lab or course interchangeably, all to refer to this online content. I'm expecting that you have already looked at some of the introductory text, and some of you may have also had a chance to read the longer summary in the online blog. If you did not, please pause this video and go to the beginning of this course to review the introductory text and optionally the online blog. And hope you had a chance to check out the Pi-square discussion page and also take the first survey. This overview has been prepared to give you a feel for the lab content, even if you skip the hands-on portions of the lab. Here is the course description, and as stated previously, the objective is to introduce you to a layered approach to maintenance and the Pi system with usage-based, condition-based, and predictive techniques. And I'm assuming that you are an experienced Pi user, meaning you have some understanding of the components of the Pi stack, the archive, asset framework, asset analytics, event frames, Pi notifications, Pi vision, and others. If not, please pause this video to first look at some Pi 101 content. To dig into all this using a picture, this screen shows the layers. And note that the x-axis is effort and the y-axis is effectiveness. At the lowest rung, you do nothing and wait for the asset to fail. And this is break fix or run to failure, and also called reactive or corrective maintenance. At the next level, for certain class of assets, machine usage is a valid metric. It may be a proxy for some other metric or combination of metrics, but the usage-based or run hours logic is easy to implement, but it is a blunt instrument. So in the next layer, which takes a little more effort, you monitor a metric that is better correlated with asset health, such as vibration, bearing temperature, and others. And the last layer is predictive, which takes more effort to implement than usage and condition assessment. And even here, it depends on simple predictive methods versus advanced predictive methods. We will expand on all those later in the course. Here we show more specifics regarding asset conditions factored into the maintenance decisions with a layered approach. In usage assessment, run hours is used as a proxy for asset condition, but it need not always be run hours. It could be any metric, such as for a pulverizer, tons of poles processed, for a motor, number of starts and stops, and others. In condition assessment, it could be for a process or a machine, and you pick some key metric that is a leading indicator of equipment failure or process efficiency. For a chiller, efficiency is measured as kilowatts per ton of cooling, or it could be some machine condition metric such as motor windings temperature or bearing temperature. In simple predictive, you use the same or similar leading indicators as from the previous step, but extrapolate the trend to predict time to failure. The advanced predictive and asset health score are covered later in the course. They are mostly discussion topics, and the content for the step-by-step is available separately and may also be in a different format.